Hello, very good day to Dr. Muhammad Nur and Dr. Nordiana. So today I'm going to present my PSM 1. My name is Melvison bin Magupai alias Malson, and my supervisor is Professor Madya Dr. Muhammad Nur Ramdon bin Bahrom. My title for PSM1 is Development of the Hybrid Solar Photovoltaic and Wind Energy Powered UPS System for Small Load Supply. For the introduction, the renewable energy are constantly replenished energy, which can be hybridized. A hybrid energy is the element combination of two or more components of energy. Renewable resources is primarily influenced by climate factors such as temperature, solar radiation, wind speed, and so on. Thus, the output of the hybrid energy system is stabilized by incorporating an appropriate energy storage system. Since installation of electricity supply, especially in rural area, costs a lot of money, an easy solution and friendly use to supply electricity for rural areas should be considered. Therefore, a hybrid solar and wind system can be applied to reduce the scarcity of electricity supply and help mitigate the problem in rural areas. For the problem statement, power outage and electricity supply happening all over rural areas have come to be recurrent problem. In this era of global pandemic COVID-19, which most of the students who live in those areas are studying from home, have been affected by these power supply issues. According to Wasoka, Saulo, and Odiambo, the conventional hybrid solar and wind system use larger space with larger construction to collect natural energy sources and required high expenses for installation. Since this system is only to supply electricity to small load application for rural areas, compact design is required to overcome the constraint of space. Hence, in this project, hybrid solar photovoltaic and wind energy interrupted power system is introduced. Next, the objective for this project. There are three objectives for this project. First, to design a charger controller for the use of charging the battery produced by a solar photovoltaic and wind turbine. Second, to develop a prototype of hybrid solar and wind UPS system for small load, consists of solar panel, mini wind turbine, charger controller, and battery. And the last objective is to test the working condition of the prototype based on the functionality in generate, store, and supply electricity energy to the small load application. Next, the research scopes. In this project, there are several materials used to complete the system, which are solar panel, wind turbine, charger controller, and battery. For the solar panel, 100 watt monocrystalline silicon solar panel will be used. And then for the wind turbine, the vertical axis wind turbine will be used. And for the motor generation for this wind turbine is using DC motor generator 40 watt. And for the charger controller, boost converter DC to DC with auto cut-off charging system will be constructed. And for the battery storage, 12 volt 50 ampere hour lead acid battery will be used in this project. Next, the methodology. Firstly, we need to study the theory related to hybrid solar and wind system and study on how solar and wind generation and storing process. Then go to study the charging circuit design, study the circuit with two sources input, and study the design of an auto cut-off charging system. Next, to determine the load and calculate the required battery, solar panel size, and wind turbine size to use in this project. And then design the circuit using Proteus. Two boost converter will be used in this charging design for solar and wind, and design an auto cut-off charging system. Then go and then simulate the circuit. If the simulation circuit does not produce current and voltage, redesign the circuit and troubleshoot the circuit. And if the simulation circuit can produce current and voltage, proceed to the next step, which is gather the component and develop the system, then troubleshoot if necessary. And then next step is to test the system, to test the functionality in generate, storing, and supply electrical energy to the load. Then collect the data and result. Next, the setup block diagram. This is the setup block diagram for this project. It consists of wind and solar panel as the generation, and from the wind and solar panel it goes to the charger controller. The function of this charger controller is to control the voltage and current to store or charge to the battery, and from the battery it goes to the DC load. The DC load will be connected in parallel connection. Next, the preliminary result. First, the system is expected to functionally well and able to supply for a small load application. And second, the charging circuit is expected to be able to charge the battery from two sources and able to work independently. Next, the load calculation for this project. In this project, I will use 6 DC LED downlight, which is 12 watt per LED, and then I'm using USB outlet, which is 12 watt, and the total for this load is about 456 watt. Next, the calculation to determine the size of solar panel, wind turbine, and battery need to be used in this system. So 80% the generation will be used for solar panel and 20% for the wind turbine. For the solar panel, the period of the solar panel exposed to the sun is 6 hours, and the efficiency of the solar panel is about 80%. So therefore, the solar panel wattage is about 76 watt, and in the market only 100 watt solar panel is available. So the calculation for wind turbine, the reachability of wind turbine to operate the wind turbine is 24 hours. Efficiency of wind turbine is about 30%. Therefore, wind turbine wattage is only 12 watt, and in the market only 40 watt motor generator is available. So for the battery storage capacity, 12 volt 50 ampere will be used in this project, and I will give extra 30% for the battery, because to ensure that the battery lifespan longer and not over discharge. Next, this is the solar boost converter circuit. The output from the solar will be expected about 15 volt, and IC555 will be used in this circuit to adjust the duty cycle and to control the output voltage. There are two fast switching diode is connected parallel at 0.7 and a 47K potentiometer. By rotating the potentiometer, the duty cycle can be adjusted, thus the boost converter output voltage. And a 4.7K resistor is connected to the 47K potentiometer output terminal to limit the duty cycle of the IC to 90%. This is because if the knob is fully rotated, the output will become saturated to 100 duty cycle. This is the graph for the current and voltage from the solar. The maximum current from the solar is about 2.2 ampere and the voltage is 12 volt. For the wind boost converter circuit, the working principle is same as the solar boost converter. And this is the current waveform for the wind system. The current is about 1 ampere and the voltage output is about 11.5 volt. Next, this is the charging circuit for this project. Both of the solar and wind output connected to the relay, then go to the battery. The Zener diode will activate when the battery reaches 12 volt and then go to the transistor. When the transistor best receive a voltage signal, the transistor will be closed circuit. The relay will be energized. When the relay is energized, then the contact will switch to normally open. Then the current passes through the LED and out to the ground. If the LED is light up, it means that the battery is fully charged. This is the current and voltage charging to the battery. The current charging to the battery is about 2.2 ampere, and the right side is the graph of the battery is being charged. The voltage is increasing, that means the battery is being charged. And that's all from me. Thank you.